Hello everyone, welcome to the Take Logic, and today I am here with very interesting concept which is fast and slow pointer. So this fast and slow pointer is a very important concept used for traversing linked list or most preferably getting the middle node of the linked list. Okay, so before moving to the linked list and all its working, so we'll first let's understand a small problem or small challenge we have. So let's consider we have a big road, as here we have a big road over here. Okay, and this each line, each line represents a milestone. Okay, so we have been given that you have given a road, you don't know the how many milestones are there. Okay, but you need to find the middle milestone, cause under that middle milestone some hidden treasure, like here we can see a hidden treasure or a lot of money are there under that milestone. And let's consider, if we have 5 milestone, for each milestone we need for visiting each milestone we need 1 minute. Okay, so our task is to find the middle milestone in less than uh, if we have 5 elements, then it will take 5 minutes if we go one by one. Okay, so in less than 5 minutes. Okay, so this is very interesting challenge. For that we have some technique, we can say in less than 5 minutes we can get the milestone. But if we follow the traditional approach, how we will be able to know which is the middle node or middle milestone we have? Is there any idea for idea? Okay, so basically let's consider, we take this. Okay, let's borrow this. Oh, sorry, let's borrow this tortoise. Let's borrow this tortoise. Okay, right, excellent. Then if we have this tortoise, if you want to find middle milestone of this road, how we can do that? So as of now we don't have any idea about how much the length of this road, how much milestones are there. But still, what we can do, we can traverse or we can visit each milestone one by one. So let's take our tortoise. He is very slow, so he will visit each milestone one by one. Okay, and he will count the total number of milestones on this road, right? So we'll count that here. Let's say we will count it verbally. Okay, so let's start. So our tortoise is ready. He visited first milestone, so count will be 1. Now he visited second milestone, the count will be 2. He visited third milestone, count will be 3. So likewise, he will visit all milestones, right? So now count will be 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we have arrived at last location of milestone, and it's located at 12th place. Okay, nice. So if we have visited 12th place, then how will came to know, or how will be aware of which location? So we'll just simply divide 12 by 2 and we will get mid element, right? So 12 by 2 is 6, right? If this is 6, so let's count where is that 6 element is. Okay, or 6 milestone is. So this is first milestone, this is second, third, fourth, 5, 6. Interesting. So we have arrived at 6th milestone. Okay, but do you think this is the middle milestone or the 6 is really middle? Because if we can see, we have 1 2 3 4 5 6 element at the right of uh, this milestone, and we have around 1 2 3 4 5. So we have 5 milestones here and we have 6 milestones here. Okay, so do you know, are you sure that this is the really middle milestone? Okay, no. Then in this case, we can consider whichever milestone is near the this milestone. Like we have consider this is the middle milestone we have got. So the very next milestone near to this is 7th milestone. So 7th milestone contains the treasure. Okay. So likewise, how much time we took, how much time our tortoise took to get that middle milestone. So our tortoise took, basically he visited all 12 milestones one by one, right? So our tortoise visited all 12 locations one by one. Okay, and I already told that for visiting each milestone we take 1 minute. We need 1 minute for visiting each milestone, right? 1 minute for one milestone. So our tortoise is taking whooping 12 minutes just to find the treasure. Okay. Okay, so 12 minutes are very long and we want to find that treasure in less than 12 minutes. So how is that possible? How is that possible? Yeah, is that possible? Because we have a very smart animal in this room. Not smart, but yeah, fast. Okay, we have fast, and that fast person is rabbit. Okay, this rabbit is very fast, like it can visit two positions at once. It can visit, yeah, so it can hop over second milestone, not just this frequent one. It can hop over the second milestone, right? Okay, then let's see whether the rabbit will be able to find that middle treasure or not. Okay, so we'll take our rabbit to the tour. Okay, let's start. But at this time, our tortoise will not do anything, right? He will be at his own place. How this the rabbit can find the treasure? But he don't know to move one location. He just only know to move at two locations. So we have started from first milestone. Then our rabbit will hop from this to this. Okay, so rabbit have arrived at third milestone. Then likewise he will hop over this to this. Okay, likewise he will go here and here. Tan 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 toon toon. Oh, and now what happened? He missed all milestones. He don't know where is the middle element or middle node, middle milestone, and middle treasure. He is just able to hop over it, but now he visited a very at the very end of the road. So he's not able to find that, cause he was not able to find. Basically just he arrived at the last location. Yeah, but we have one idea. We can take both these tortoise, we can take this both tortoise and this rabbit with each other. Okay, so if they are with each other, they will be able to find the middle location milestone in 12 minutes, right? In less than 12 minutes, right? So we have 12 milestones, so they will be able to find in less than 12 minutes. Okay, so and they can share that treasure along with each other after after they will be able to find the location in less than 12 minutes. Okay, so let's consider if this tortoise goes by one milestone at a time, and this rabbit goes by two locations or two milestones at a time. So at the time, if you say when our tort when our rabbit will be here, at that time where our tortoise will be? It will be at very interesting position. So it will be, if our rabbit visited here, then it will be uh, at if let's consider, like if we have rabbit at 12th position, cause he is able to traverse at a time two milestones, then rabbit is only able to traverse only one milestone at a time. So we'll divide 12 by 2 and it will be 6. So basically our tortoise will be at 6th location. 1 2 3 4 5 6. Okay, so are you able to see anything interesting over here? Or we can say we can just simply say, yeah, here interesting thing is we have actually two middle elements over here. Okay, but the tortoise is over here. So we can simply say, whenever our rabbit visits the last location, or the very empty the after like very last location, not the 12th milestone but after 12th milestone, then at that time our tortoise will be here. Okay, interesting. Basically, okay, so if our tortoise visited this milestone, then yeah, we know that they worked both intelligently with each other, and now even though tortoise is very slow, he's able to find the treasure, and now this treasure will be shared by both tortoise and rabbit. Okay, so basically we are using this same concept for finding middle node. We will able to find the middle node of the linked list. Okay, let's take both of them to tour. So here let's take them at proper location. Okay, so now focus. So we have been given a linked list. We have some elements into the linked list, and we need to find the middle nodes of linked list and return its value. Okay, so currently as we can see, this linked list having 3 4 5 6 elements, right? So if this linked list have 6 elements, then generally we can see we have these two elements in the mid of linked list. Okay, so if we have two elements into middle of the linked list, basically when our list is of even size, so we can see that 6 divided by 2 is equal to 3, and 6 is even number, right? So if this is even number, then we will get the two middle nodes, right? If we have two middle nodes, then we need to consider the second middle node. So then we need to consider the fifth node, and we need to return fifth, right? Okay, and we need to do this in less than big O of n time. Okay, so basically we'll use these as we discussed, we will use this fast and slow pointer. Okay, so we have initialized the tortoise and the rabbit at this location at the head of the linked list, right? Okay, so for very first time our tortoise, so for very first time our tortoise will move by one location. Okay, then our rabbit will move by two location, then our tortoise will move by one location, then our rabbit will move by two location, again our tortoise will move by one location, and then will our rabbit will move by two position. Here we can see whenever our rabbit visits the null, or we can say the last element, we have the tortoise at very middle location, right? So it is very clear that whenever our rabbit visits the last node or the null node, we get our we get our tortoise at the very middle of the linked list. So basically we'll just return this file node. Okay, so likewise if we consider that so we did this for, so the size of this linked list was odd, sorry, even. Let's do same thing for the odd sized linked list. Okay, so basically we'll take so we'll take our tortoise, we'll take our rabbit. Okay, so let's start. Our tortoise will go one by location, our rabbit will go by two location, our tortoise will go by one location, rabbit will be go by two location, tortoise will go by one location, our rabbit will go by our rabbit will go by two location, then will our tortoise will go by one location, our rabbit will go by two location, then our tortoise will go by one location, and then our rabbit will go by two positions. Something is wrong here, something I missed, sorry. Let's again start from the very first time. Let's take them to their home. So tortoise will visit by two location, sorry, rabbit will visit by two location, tortoise by one, again rabbit will move to two position, tortoise will be one, the rabbit will move by two location, our tortoise will be by one, again our tortoise our rabbit will go by two location, and our tortoise will be by one. Okay, so very interesting. You can see here we are able to find the middle node of the linked list, because we have 1 2 3 4 element on the left side, and we have 1 2 3 4 element on the right side. So indeed this is the middle node. Okay, so we are able to find the middle node. Okay, so when is the stopping criteria, when we can return the middle node? At the time of when when basically rabbit hits the last node, or when rabbit hits the null node. Rabbit can be here at the null node also, and it can be here also. Okay, so in this case, cause since this is even number of nodes are there, so rabbit will be at the null node, and since this is odd, it will be at the very last node. So likewise, we will be able to get the middle position of the linked list. Okay, so if we got the idea behind that, so let's have a code. We'll write code. We'll just write a pseudocode for that. Okay, so let's consider. So if this is the head of linked list, so if our linked list of type, okay, if we have linked list of type linked list, so we'll then declare a tortoise tt, and then we'll declare rabbit rb. Okay, and then we'll first initialize it with the head. Both of them will point to the head node, right? So okay, after they will point head, so then our while condition, then stopping criteria is either this rabbit is at last location or at the null location. Okay, so our stopping criteria, like we will move this to both of the pointer till our rabbit hits last location of the linked list, or if it is pointing to the null. So at this time, basically our tortoise will be somewhere around this. Okay, so at this time we will return the tortoise. So tortoise node will contain the middle element, right? So let's write a while loop for that. So basically, while this will be rabbit, while rabbit is not equal to null, sorry, while mm, rabbit is not mm, 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 rabbit will be at the last location. So while rb is not equal to, while rabbit is not equal to null, while rabbit, okay, okay, while rabbit is not equal to null and rabbit dot next equal to null. So basically rabbit dot next, so like this node dot next, if this node dot next is equal to null, then we know that rabbit is present at this location. Okay, rabbit is present at this location. So at that point we'll be get out of the loop and we'll will return the middle node. And in this condition, rabbit will be point to this. So we can say in this case we are checking whether rabbit is not equal to null. Yeah, but we can see rabbit is null because it is pointing to the null pointer. So if it is pointing to null pointer, then we'll get out of the loop, right? If either rabbit dot if this pointer dot next is null or it is pointing to the null, then we'll get out of the loop. Okay, then we'll get out of the loop and we'll return tortoise. Okay, this will return. Okay, and if this condition is not true, okay, if rabbit is not at the last location, then we'll simply increase tortoise. We'll just move tortoise to the next. Okay, so tortoise will be tortoise dot next, and we'll move rabbit is equal to rb dot next. So tortoise will move by one location and rabbit will be moved by two location. So basically this is how the code of fast and slow pointer, or we can say rabbit and tortoise. So like by this way we will be able to find the middle node of the linked list. Okay, so it will just take less than big of n time. So this is how it looks like. Okay, thank you very much for watching this video. I will share the code of this along with them in comment box. Thank you very much.